Hey everybody, this is a video on chapter 3.3, properties of logarithms. So we introduced logarithms in the last chapter 3.2, looked at the graphs, looked at moving them around by, transformations through addition, subtraction, multiplication, and all that. So now we're going to get into like how you can manipulate these expressions, what you can do. So the first thing they talk about here in chapter 3.3 is what's called the change of base formula. So it says here most calculators have only two types of log keys. One for common log, which is base 10, and one for natural log. That's not true anymore. This text is old at this point. But just to show you what they're talking about here, let's see if I can, like in this calculator here, this version I have, which is this is like software on an old phone I have. You can't download this thing anymore. If you guys figure it out, let me know. But it's an old software called Wabbit, W-A, like W-A-B-B-I-T. Anyway, if you go to, well, first, this log right here, here, let me blow this up. You got two logs over here on the left, right? You got logarithm, that's base 10, right? So if I take log of base 10 of 10, I should get 1. And then natural log, which is base e, right? And base e, so if I were to take the natural log of e, then I should get 1. Now, if you want to take the log of some other base besides base 10 or base e, on this calculator, you just go to math. And if you scroll down, whoops, well, let me try that again. Math, scroll down. It's right there, log base. So when you choose that, it opens up, to variables there, one for base. So I could do log base 2 of 2, which will give me 1. But if you have an older calculator, let's say I think I have one. So some of you might be using these older Ch3.3s. When you go to math and scroll down, you don't have that log base option, right? So if I wanted to take, let's say, log 2 base 2, I could do what's called a change of base formula, which means it's like a trick, really. You could take the log, this is base 10 of 2 divided by the log of whatever base it is you want, right? And the base here is 2 as well. So it'd be log base 2 of 2, and that would give me the 1 that I want. So to give a better example, let's say I were to do log base 5 of 2. That gives me 0.43, blah, 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 right? So if I want to do that on this old calculator, I could do log of 2 divided by log. Notice I'm using log base 10 for both of 5, and that would give you that same value, right? Or if I wanted to do, like, let's say, I'll do another one. Let's make this log base, I don't know, 9 of 2. So now I get that. So I would do, and I could do natural log instead. I could do natural log of 2 divided by natural log, as long as you use natural log again, of 9, and that should give me that same value. Just to show you it doesn't matter that I use natural log or log, I could do log of 2 divided by log of 9, and I get the same value. Okay, so that's called the change of base formula. And that's described right here. page 219 in your textbook, right? And here they're showing you could use log base whatever of x. You could do natural log of x over natural log of a, or you could do log base 10 of x over log base 10 of a, as long as the base you use are the same. These two are the most commonly used because that's what's on most people's calculators. All right, so that's it for there. So that's called the change of base formula. Now, in the next part, we get into some 3 properties of logarithms. Notice they've got logarithms and also natural logarithms. They're identical, really. The value of a over here would just be e, right? So that'd be log base e. But they're the same rules, pretty much. So the first one says that if you have the log of a product, you can break that up into the sum of those 2 logs, of those 2 factors, right? U is a factor, V is a factor. So let me write that down here. So properties of logarithms. Number 1, log base A of U times V can be broken up into log base A of U plus log base A of V. All right, and that comes from the fact of, remember, these are inverses of exponentials. If you remember in exponentials, you could have like x to the a times x to the b, and that equals, if you remember, x to the a plus b, right? So an example would be x squared times x cubed is x to the 5th. So when you're multiplying, you actually add the exponents. So it's related to this same property for exponentials. And the next one is the same thing, it's just for division. So the next one says log of whatever base over u of u over v, and that's just a subtraction of the 2 logs. So that's log base a of u, take away log base a of v, and that's related to a very similar property of exponentials, where if you have log base a divided by if you have x to the a divided by x to the b, that's just x to the a minus b. So an example of that would be like x to the 10 over x to the 2 is equal x to the 10 minus 2, which is x to the 8th. All right, and then the third property is dealing with exponents in logs. So if you have log base a of u raised to some power, let's say n, then that n can become a factor of the whole thing. So it can be brought out to the front like this, u, right? And that's related to, I think, a power raised to a power. So if you have x to the a raised to the b, I think that's just what, x to the a times b. I believe it's related to that exponential rule that we learned back in chapter 3.1. All right, so let's look at some of these examples here. So here it says example 3, write each logarithm in terms of natural log of 2, natural log of 3. So let's do that. So looking at example 3, natural log of 6. Now, if I want to break that up into natural log of 2, natural log of 3, you know that natural log of 6 is 2 times 3, right? And then using this rule up here, I can say, okay, well, since this is a product, it can be broken up into a sum of 2 logs, so that's natural log of 2 plus natural log of 3. So now I've rewritten this in terms of natural log of 2, natural log of 3. And for part B, so that was A, B, natural log of 2 over 27. Well, that could be broken up into a subtraction, right? So that could be natural log of 2 minus natural log of 27. But I'm supposed to write it in terms of natural log of 2 and natural log of 3, so this needs to be broken down somehow. Now I know 27 is 3 to the 3rd power, so I could rewrite this as natural log of 2 minus natural log of 3 cubed. Okay, now I've got natural log of 3, and by this last property, I know that this exponent can be brought out to the front here. So this can be written as natural log of 2. We zoom in on that so you can see a little better. Natural log of 2 minus 3 times natural log of 3. Right, so all I did was I brought that 3 out to the front right there. And made it a factor of the whole thing. So that's an example that you could that is written in your book on that first page of chapter 3.3. All right, here, example 4, it says use the properties of logarithms to verify that negative log base 10 of 1 over 100 is log base 10 of 100. Well, that's a negative 1 out front, right? So it can be taken back and made into a exponent, right? So that negative 1 right there becomes that exponent on 1 over 100. So 1 over 100 raised to the negative 1 means you would flip that over and make it 100. So you can see right here that's exactly what they do. They take that negative. First, actually, they change 1 over 100 to 100 to the negative 1 power, right? And then they take that negative 1, they kind of do it a little different, and they move it out to the front with that negative 1. So now you got a negative 1, which turns into positive. I'll do it a little differently. The way I thought about it was a little bit different. So starting with negative log, this is example 4. Negative log base 10 of 1 over 100. Okay, so I know that negative 1 is really, that negative, could just be a negative 1, right? So that's I'm gonna move that here. So now that becomes positive log base 10 of 1 over 100 raised to the negative 1 power. And when you raise something to the negative 1 power, you just flip the fraction, or you find the reciprocal. So that becomes log base 10 of 100 to the positive 1 power, which, you can write like that or not show it at all. So that's example 4. All right, now here you're expanding. So you've got these complicated logarithms, and the exercise is trying to use all the different properties to expand this thing out as much as possible, right? So let's take a look at example 5, part A. So for part A, you've got log base 4 of 5x cubed y. Alright, so I've got basically right here, I've got three factors. I've got 5, I've got x cubed, and I've got y. So those can be broken up into separate logs, and they would all just be added. So that's log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Okay, and then this can be brought out to the front as a factor, so you want to do that. So that would be log base 4 of 5 plus 3 times log base 4 of x plus log base 4 of 5. And now it's completely expanded out. Okay, example 5b. We've got natural log of the square root of 3x minus 5 over 7. Alright. So I want to expand it as much as possible. Make sure that I get rid of any exponents. If I have them, turn them into factors. So here we have, we're taking the log of a quotient. Right? This is a quotient. So that could be broken up into two logs through subtraction. So natural log for the square root of 3x minus 5 minus natural log of 7. Alright, what about that square root? Well, if you remember, a square root is the same as 1/2 power. So I'm going to rewrite this as natural log of 3x minus 5 to the 1/2 power minus natural log of 7. Okay, now that 1/2 can come out to the front, so to get rid of that power, because remember we're trying to expand it as much as possible. So natural log, 1/2 times the natural log of 3x minus 5 minus natural log of 7. And that should be it. I can't break this up because that's not a product, right? That's not multiplication or division. Remember, in the properties we learned, you can only break up multiplication, division, right? Now, you can work backwards. If you have two different logs and you want that are added together, as long as they have the same base, you could write it as a single log. So all these do go in reverse. But this is not two separate logs, right? This is one log of this minus this. So that's as far as we can go with that. And make sure the book agrees. Right, there's the answer for the text, so that's correct. Okay, here you're just doing the opposite, right? You've got these expressions that are expanded out, and you're trying to condense them as much as possible. So let's look at one of those. So example 6. Okay, so I've got, let's see, 1/2. So this is A. 1/2 log base 10 of x plus 3 log base 10 of x plus 1. All right, so since this is a sum of two logs, we can write that as a product. But before I do, I need these to go away, right? So we got to take care of that first. So this 1/2 is going to become a power on x, and this 3 is going to become a power on x plus 1. So this becomes log base 10 of x to the 1/2 power plus log base 10 of x plus 1 to the 3rd power. Alright, and then x to the 1/2 can be just written as the square root of x, which they probably do that. Not that you have to do that, but you can. So let's just ignore that for now. Since I now have just a log plus another log, and they're both base 10, I could write this as a single log base 10 of this times this. So the x to the 1/2 times x plus 1 to the 3rd power. All right. And then the only other thing I can think of is just to change that to a square root. So that would be log base 10 of square root of x times x plus 1 cubed. Right, and that's the expression I'm taking the log of. So that should be as condensed as it gets, right? As condensed as it gets. So let's see. Yeah, it's right here. So that's how you work these out. And I think that's pretty much it, except for applications. Right? We've already done some applications, and this is pretty much the same stuff. I'm going to look at some of these problems here, these problem sets, and looks like this is not readable. So here it says, in exercise 17-38, use the properties of logarithms to expand the expression as a sum, difference, and or constant multiple of logarithms. Assume all variables are positive. So I'll just do a couple of these, and then we'll do some of these others. All right, so let's look at, I don't know, 20. Problem 20 is log base 10 of y over 2. Okay, so since that's division, I'll just change that to subtraction of two different logs, log base 10 of y minus log base 10 of 2. Oops, got that mixed up. Base 10 of 2. And that should be it for that. Going down here, something a little more complicated, like, I don't know, this mess. Let's look at 28. So natural log of x squared minus 1 over x cubed. Notice it says where x is greater than 1. They do that because there's a domain problem, I'm assuming. If x is negative, you're going to have trouble with the domain, right? So in order for this to be a logarithm, you have to restrict the domain for positive numbers greater than 1. I won't go into why, but you could probably investigate it and figure out it has something to do with taking the log of the negative. All right, so let's break this up. So I can break that up into subtraction, natural log. Sorry, that's ln. That's natural log of x squared minus 1 minus natural log of x cubed. Okay, what else could I do? Well, that 3 could go out front. This factors, so I'm going to factor that. So let's see what I get when I do that. So I'll just write it down here. So natural log of x plus 1, x minus 1, minus 3 natural log of x. So I took that 3 and put it up front, and I factored x squared minus 1. Now I've got a natural log of a product, so I could break that up into addition. So that's natural log of x plus 1 plus natural log of x minus 1 minus 3 times the natural log of x. And I believe that is about as stretched out as I can get that logarithm. All right, so we've broken it up into actually 3 different logs being added and subtracted. Okay. Let's look up here. Now here you're just doing the opposite. It's all expanded. You want to shrink it. So we'll look at something easy like, I don't know, 44. So 44 is 2/3 log base 7 of z minus 2. Okay, so that, first thing I'm going to do is make that a power, right? So that's going to become, I think that's all I can do. Condense, we're just trying to condense it. There's not much else. Base 7 of z minus 2 to the 2/3 power. So now, just to let you know, the answer in the back may, since you have a fractional exponent, you could break that up into log base 7 of the cubed root, because it's 3 on the bottom, of z minus 2, but then this would be squared under here. So that may be the way the answer looks, but these are both correct. All right, how about 48? 2 natural log of 8 plus 5 natural log of z minus 4. So that 2 becomes a power on 8, so that's natural log of 8 squared plus natural log of z minus 4 to the 5th. Okay, now since they're being added, I can put this into a single logarithm. So natural log of, now 8 squared is just 64, so I'm just going to write 64 for that. And then this would be z minus 4 to the 5th power, like that. So basically 8 squared times z minus 4 to the 5th. And that should be as condensed as we can get that. All right. So that was 48. Let's go into like one of these crazy looking ones, like 52. I'm not taking the time to check my answers. I want you to do that though. If those of you that are out there are ambitious enough to check my answers and find my mistakes, I'm going to give you extra credit for that, right? I hope I don't make any though, because then I have to make a new video. But you are welcome to check them. Please do, and let me know if you find them. And you'll be rewarded for that. All right, so 2 natural log of z minus 5. Okay, I think I copied that down wrong. I mean, right. All right, so what do I want to do first? I think, well, there's a couple ways I can go. I can can put these together as one logarithm. So I'll do that first. This would be 4 times the natural log of z times z plus 5 minus, and that 2 I'm going to put on there, so that's natural log of z minus 5 squared, and I think I'll take that 4 and put it right there, because that would be the next step, and I don't want to write a whole new line for that, so I'm just going to erase that 4 and put it right there. Alright. Now I can do a division, because I've got subtraction, so this would equal natural log of the big division problem, right? So this would go on top, z times z plus 5 to the 4th power over z minus 5 to the 2nd power. And that should be it. Alright, so that's how you work this set. What's going on here? Exercise 57 and 58. Compare the logarithmic quantities. If 2 are equal, explain why. Alright, we'll look at 58. So problem 58 is log base 7 of 70. Log base 7 of square root of 70. And then there's log base 7 of 35. And then we've got this 1/2 plus log base 7 of square root of 10. Alright, so are any of these equal? Let's see. What can I do? Now, I could just plug these into my calculator and see if they're equal. That's one way to do it, but I don't think that's what they intend. I think they want us to play around with these and see, like this would be, what, 70 to the 1/2 power. And then that 1/2 could come out front, couldn't it? So that would be 1/2 log base 7 of 70. That can be broken up, right? 7 times 10. I'm just trying to figure out what other forms this thing could take. So this would be log base 7 of 7 times 10. Expand this out. I have not explored this before this. Okay, so this could be log base 7 of 7 plus log base 7 of 10, right? So I'm going to do 1/2 log base 7 of 7 plus log base 7 of 10. Log base 7 of 7 is 1, isn't it? So that's 1/2 times 1 plus log base 7 of 10. And then you can multiply that out. Right? This could be expanded. So that becomes 1/2 plus 1/2 log base 7 of 10. Alright, and see, I think it's going to go to that. And then that 1/2 can be brought over here as an exponent. So that would be 1/2 plus 1/2 log base 7 of 10 to the 1/2. And 10 to the 1/2 is a square root. So finally I can get to 1/2 plus 1/2 log base 7 of the square root of 10. So this one is equal to this one. These two are equal. And I kind of did what's called an identity, right? I messed around with this until I figured out how to turn it into this. Now log base 7 of the square root of 70, I don't think is equal to this. Let's see, what can I do with this one? So I'm going to So this could be log base 7 of 7 times 5, which is log base 7 of 7 plus log base 7 of 5. So it's very similar to what I did over here. So this is just 1 plus log base 7 of 5. I don't think there's anything I could do with this one. So this one's not equal to the other two that I can see. So that's the idea, I think, behind these problem sets. I can't get this to look like this or to look like this, as far as I can tell. There may be a way. If I'm wrong and you figure it out, let me know. Give you some extra credit. All right, so that was 58. In the next section, it says, find the exact value of the logarithm without using a calculator. If this is not possible, state the reason. All right, so let's look at 60. Now the trick to these is knowing like certain powers. Like I know 5 to the third power is 125 because 5 times 5 times 5 is 125. So I think this is going to end up being just like -3 just by looking at it. But let me write it all down and make sure that's right. So log base 5 of 1 over 125. All right, so I'm going to rewrite this as log base 5 of 125 to the -1 power, right? So I just flip the fraction over, which changes the power on it from 1 to -1. Now I know that 125 is 5 cubed, so this would be log base 5 of 5 cubed raised to the -1, right? And then I'm allowed to multiply those, so this is log base 5 of 5 to the -3, and then remember that rule, if these are the same, then the value of this whole thing is just equal to the exponent, so this is -3. So log base 5 of 125 is -3, and we could, confirm that by putting that in our calculator here. So let's see, go to math. Oh, this is the old calculator, it doesn't have a change of base. So let me use my newer calculator. So if I do math, log base, starting with the original, that's 5, and this is 1 over 125. I should get -3. There it is. But, you're supposed to be able, you need to be able to do that without a calculator. So if I were to give you a quiz without a calculator, you should be able to figure this out. Okay, let's look at 66. 66 is log base 2 of -16. Right, so now I know -16 is 2 to the 4th. So log, what do I want to do with that negative? I'm trying to think. I don't think this is possible because you can't take the log of a negative. So there's the problem. So if I do math base 2, and if I put 16 in here, I'm going to get an error. Nope, I get imaginary number. So it can't be done, right? So this is no can do, because you can't take a log of a negative. Negative 16 isn't in the domain, right? Has to be positive. All right, so that one you can't do. So let's try another one. 60, let's do 70. For problem 70, we have natural log of 4th root e to the 3rd. All right, so I'm going to rewrite this as natural log of e to the 3rd raised to the 1/4 power, because that is a 4th root, and which is the same as 1/4 power. And now I can multiply those two powers. So that's natural log of e to the 3/4. Now remember, natural log is base e, so these are the same, so the answer should just be 3/4. Right, because natural log of e is 1, so you're just going to get 3/4. Another way to think of it is, maybe if I were to back up a little bit, you can bring that 3/4 to the front, so that's 3/4 to the natural log of e, and then you know natural log of e is 1, right? Natural log of e, oops, that's pi. Delete e is 1. Okay, so this is 3/4 times 1, which is 3/4. All right, so these are like little puzzles. They're kind of enjoyable. Once you get the hang of it, they're kind of fun to try to reduce them or simplify them. Let me do one more of these. Let's see, how many more are there? I'll do one more of these. Let's try 74 and see how far I get on that. So 74 is log base 4 of 2 plus log base 4 of 32. Okay. I can multiply those. So that's log base 4 of 2 times 32, which is 64. 64, I think, is 4 to the 4th power. Nope. 4 to the 3rd power. Yeah. So this becomes log base 4 of 4 to the 3rd power, so I get 3. Make sure. So looking at the first one, do math, log base of 4 of 2 plus math log base of 4 of 32, and hopefully I get 3. There it is. Long lesson. Sorry, I want to get through the whole thing. I'm almost done, and then we'll do another one for some of the applications. I might have to stop, actually. I think I better. This is a lot longer than I remembered. So I'll stop here. That got us through page 223. I'll start on page 224. in the next video. All right. Let's see. That's not what I want. I could never figure out exactly how to get out of here, guys. Sorry about this. All right. I think this is it. Thanks for watching. God bless you guys. Have a great day.